My name is Lars Furenlid. I'm a professor in the Department of Medical Imaging in the College of Medicine here at the University of Arizona. I also have a secondary appointment in the College of Optical Sciences, which is where I teach. My work here at the university is involved in the development of instrumentation that advances the state-of-the-art in spatial and temporal resolution in the imaging techniques known as molecular imaging. This first system I'm going to show you is called Fastpic 2. So this system is a tomograph, and a tomograph is a system that recovers a three-dimensional view of an object by measuring projections in all kinds of directions and then reconstructing from those two-dimensional images the three-dimensional distribution of the molecular imaging agent. In this Fastpic systems, we surround, in this case, the mouse or the rat with enough cameras that we can acquire all of the projections required for tomographic reconstruction in parallel at once. What this provides us with scientifically is the ability to monitor the dynamics of radiotracer distribution, which is the wash-in, for example, of a drug into a target area, followed by the washout that occurs as compounds are cleared by the body. So this system is known as ModPet. ModPet is a dual modality system. It first shoots an optical image of the mouse or pairs of mice which are on the sample stage, and then you rotate the system in such a way that the gamma ray cameras, which now sit above and below, can be brought down into very close proximity. The novel thing about ModPet is that the cameras are brought down very, very close to the mice, and that allows us to get good angular sampling and get very high quality reconstructed images. In this laboratory is a system that we call Fastpic 3. Fastpic 3 is our latest generation of the Fastpic class of instruments that surround the imaging subject with cameras from all directions in order to be able to capture truly dynamic three-dimensional images. So the Fastpic 3 system is a dedicated rodent brain imager. The purpose from the very beginning to work on the problems related to Alzheimer's disease, Parkinson's disease, and related neurodegenerative disorders. The Fastpic 3 system has 20 cameras that are arranged looking in at the common field of view. And the idea is to get, really extend and get the highest resolution mouse brain images ever collected on a mouse SPECT system. So in this laboratory, I'm going to show you something that you rarely see, and that's the inside skeleton of our most recent system. This system is called SPECT. So in this system, we're working to make the imager itself smart. It will make a first pass at assessing the data from a so-called scout scan and look at the distribution of activity inside the object and make a decision about where you might want to collect higher resolution or more sensitive data in order that you can make the optimal use of the imaging time spent into the system. The analogy for the human body is a whole body scan where you see broad patterns of distribution, but then the ability to zoom in on a particular organ or tumor or suspected region and get very high resolution data. So the broad objective of our research is to add to the minimally invasive tools that can be used to aid in the diagnosis and treatment of disease. And we really feel adaptive imaging techniques is going to be one of the key approaches in the future. The University of Arizona has been tremendously supportive of our research and has offered really a unique environment to allow us to pull together the resources available for this technically challenging research. Among the things I'd like to cite are the strong collaborations between the College of Medicine and the College of Optical Sciences, our access to absolutely terrific graduate students, our ability to create multidisciplinary teams that bring together everything from the biologists with the fundamental problems, physicists who can address and develop new technology, mathematicians who can work on the development of algorithms, and support from administration all the way down to the department level. This story is not complete without recognizing the contributions of all of my colleagues, our very talented graduate students, and also the many talented undergraduate students who have participated in this research.